theory, and here De-Moivre's theorem is stated here. Amen. It states that for any rational number n, the value or one of the value of open bracket cos theta plus I sin theta close bracket raised to the power n is equals to cos n theta plus I sin n theta. This is for any positive integers. When we say positive integers, it means this is plus 1 or plus 5 or plus 6 or plus 10. Is that clear? But if they refer to negative integer, we are talking about either minus 3, minus 1, minus 5, minus 10, like that. Integers. Is that clear? So take note. So now it states that if we have a complex number of this form, it means we can write it in this form. Then what if it is negative integer? It means cos theta plus I sin theta raised to the power of minus n. Yeah, you can know that this is a negative integer. Why? Because of this operation here is negative, true or false. So it means we can rewrite this in this form. It is either 1 all over, you apply indices here, cos theta plus I sin theta raised to the power of n. This is the same thing as this, or this is the same thing as we can rewrite this in this form, or cos open bracket minus n theta plus I sin open bracket minus n theta. This and this, they are all the same thing. Are you following? Do you understand? So this morning, I'm going to solve one or two problems here in De-Moivre's theorem. Is that clear? So take note. Okay, let's solve. Amen. Let's solve this question. It says if example, let's consider example, if z is equals to cos theta plus I sin theta. Amen. Then to now show if z equals to this, show that amen, z raised to the power n plus 1 all over z raised to the power n is equals to 2 cos n theta. Yeah, it's simple as ABC. Is that clear? I'm going to show you, break it down step by step. You will learn and understand. Amen. Please don't forget to share this video. Okay, so let's solve this problem. Okay, so this is z equals to cos theta plus I sin theta. Amen. Then given as z raised to the power n plus 1 all over z raised to the power n, right? As it is, you don't need a set show that the left hand side is equal to this. That is what we are going to do this morning, this morning. Okay? You can now see that here we have z raised to the power of n plus 1 all over z raised to the power of n, true or false. So you don't need a prophet to tell you that this particular question is coming from what? Is from De-Moivre's theory, true or false? Yeah. Why? Because De-Moivre's theory, this is how it is. So if we have something of this form, we can write it in this other form, true or false? Okay, so that is what I want us to do. But before we do that, you know, we are dealing with complex numbers, true or false? So if assuming at the end of the day you have 1 plus 2 plus I, you know, as long as complex number is concerned, you cannot just remove the answer like this. it is not ideal, amen, as long as mathematics is concerned. What you need to do is, you cannot just stop here like this. Why? Because of this. This is a complex number, and complex number can never be in this form. Denominator, no. Your answer is incomplete. Is that clear? So I'm going to break it down for you to understand and learn. Amen? Okay. So if you can see what I am saying, look at it. Look at the board very well. See with me that if we have 1 all over 2 plus I, what you need to do, you have to conjugate the denominator. Amen? Okay? You should conjugate this denominator, this complex number. How? Conjugate means this is equals to 1 all over 2 plus I times, conjugate the denominator, it means the conjugate of this complex number. What is the operation here? Is plus, so it will turn to what? Minus 2 minus I all over 2 minus I. Is that clear? So now the whole thing will now be 1 times 2 minus I all over 2 plus I times 2 minus I. Amen? So this we're going to do as 1 times 2 is 2, right? Going to give us 2, then 1 times minus I all over 2 times 2, 4. 2 times minus I is minus 2I, then plus I times 2 plus 2I, then I times I, plus I times minus I is minus I squared. True or false? Yeah. So if you agree with me, it means you don't need the prophet to tell you this and this will go. I'm doing this because of, here we are going to do something like this exactly. So please take note. So this will be 2 minus I all over 4 minus I squared. But mind you, our I squared is always known as what? Minus 1. True or false? So if minus 1 times this, minus is going to be plus. True or false? So we are going to have 2 minus I all over 4 plus 1, which is 2 minus I all over what? 5. Then this is equals to either 2 all over 5 minus I all over 5. Yeah. So this is the right answer. This is where you are supposed to stop. If you have anything like this, don't stop here. Your answer is incomplete. So you have to conjugate because of the complex number. But supposing it is in this form, yeah, is okay. You can stop here. But what if it is 1 all over I? Yeah, you cannot just stop here. You have to conjugate because since this is a complex number, so here is positive. What you need to do, times minus I all over minus I. Yeah, that is what you are supposed to do. So at the end of the day, minus I all over minus I squared. Then this is equal to minus I all over, because I squared is minus 1 times this 1. So you can now see that at the end of the day, you are going to have minus I. So all these things will come to play as long as this problem is concerned. So do you have any question? Please drop it in the comment section. If you have any question, drop it in the comment section. If there is no question, let's proceed. Okay. So if there is no question, so with this explanation, let's go ahead to solve this very problem that will help you. Amen. Okay. So now it means this is Z complex number. So anywhere you see Z, you substitute in. So what we need to do here is this is equals to, we said show that this is equals to 2 cos n theta, right? So let's substitute in Z is cos theta plus I sin theta, all in bracket, raised to the powers of what? N, right? Then plus 1 all over cos theta plus I sin theta, open bracket, close the bracket, raised to power n, true or false? Okay, so as you can see now, this is a De-Moivre's theorem, true or false? So we have to establish the De-Moivre's theorem as it is now. This will now be, this is going to give us, from this, it means this is cos n theta plus I sin n theta, true or false? Now what we have here, plus 1 all over, this is cos n theta plus I sin n theta, true or false? Okay, so now we are going to do something here. You remember when I explained 1 all over 2 plus I, true or false? So if you compare this and this, they are almost the same thing, isn't it? True or false? Any question? Do you have any question? No. True or false? It's true, right? Okay. So as you can see now, look at it here. This and this are the same thing. So what are we going to do? We have to conjugate this. But mind you, there is plus here. So let us conjugate this. Let's conjugate this. Okay? So let us conjugate this. So if we are to conjugate this, let's have it in this form. Yeah. Here is 1 all over cos n theta, amen? Yeah. Plus I sin n theta, then that is the operation here, plus, so it will now be minus cos n theta minus I sin n theta, then all over cos n theta minus I sin n theta, amen? So 1 times this, then this times this, amen? So we are going to have cos n theta minus I sin n theta, then all over cos n theta plus I sin n theta, then times this, open bracket, cos n theta minus I sin n theta, amen? Amen? Yeah, we are just trying to evaluate this. So, and this is how you are going to evaluate it, as I mentioned it to you, because here, the denominator here is a complex number, true or false? It's true. So, this will now be equals to, let's first consider the denominator, or we write this, cos n theta minus I sin n theta, right? Okay? Yeah. So here, cos n theta times cos n theta, we are going to have cos square n theta, true or false? Then cos